Okay, so hopefully everyone can see my slides and hear me okay. Thank you for having me today. As Becky said, my name is Sarah Romkey, and I'm the Archivematica Program Manager for Artefactual Systems. And Artefactual is an affiliate member of the Open Preservation Foundation. And as affiliate members, we help to maintain and release Fido, or Format Identification for Digital Objects. So today I'm going to give you an update on Fido to let you know about some new features in our Fido 1.3.3 release, which just happened today, as a matter of fact, so it's kind of breaking news. And we'll also talk about the significance of file format identification more generally. So here's our agenda for today, and just a note that this isn't going to be like a terribly technical discussion. We'll get into definitely some technicalities of format identification, but I kind of thought that what might be more helpful for us today is a bit more of a basic overview, some reminders for some of us about why we think about format identification so much and what some of the issues are. We'll talk about some different tools that are available for format identification in addition to Fido, and how in some ways they're similar and in some ways different. We have some sample workflows for file identification to go through, and I've taken these very shamelessly from the Archivematica community because that's the community of users that I know the most about, but I think it's generic enough that hopefully you can get something out of this even if you're not an Archivematica user. And then finally we'll finish with update on the Fido project and talk about some of the updates that we've included in the 1.3.3 release, which, as I mentioned, just was released today. So why do we place such emphasis on format identification? It certainly is one of the most basic digital preservation actions that you can take on digital objects. If you cannot identify and record the formats you are preserving, it would seem you're missing one of the most fundamental data points about your digital objects. More specifically, our ability to understand a digital object on a technical level hinges on understanding its file format. Further digital preservation actions that you wish to take on the object, including characterization, validation, and metadata extraction as examples, are dependent on having accurate understanding about the format, which is not necessarily to say that you cannot undertake these actions using different tools if you have not first identified the objects using a tool like Fido. Certainly some tools like FITS or Jove have other functionalities, including characterization and identification as sort of a more all-in-one approach. So aside from gathering all of this technical knowledge that you are able to about your objects while you're processing them, format identification is also part of a longer-term preservation strategy as well. So whether you're planning to undertake migration or normalization or emulation of your files, the tools that we need to perform these tasks require detailed format information about the digital objects. I found this other perspective on format identification in a really excellent blog post by Ross Spencer on the OPF blog. And his blog post is titled, "What is the Point? The Motivation for Adopting Different Tools Inside the Digital Preservation Workflow." And in the post, Ross talks about format identification, validation, and metadata extraction. And I thought that this point about format identification was very relevant. As he points out, this concept of format identification is closely related to records management workflows and also related to archival appraisal. And I'm sure you can think of lots of analogies in the analog world to understanding the medium of the records that you're working with. And I'm also sure that a lot of you have been faced with some older media of some kind, floppy disks that have come in with some collection or other, and as you struggle to identify the file formats, you may be sort of wondering, did the donor or the depositor even know what this was? Or perhaps they knew at one time, but they've forgotten, they haven't used these files in a very long time. Or maybe the depositor or the donor of the material is not the same as the creator of the material, in which case they're not going to be able to help you shed any light on the formats on the media either. So this is a definite tangent, and I hope you'll stick with me for just a couple of minutes because it's an example of a collection and a story that I think is really interesting. And it's sort of one of these examples where these floppy disks come in and the files on them may seem meaningless in some ways because you have no idea what they are. But this example comes from a colleague at the University of Victoria here in British Columbia, and he's done a really deep dive into some, to him, unknown formats that came on these flop of an artist papers that were donated to the university. And this colleague, his name is John Durno. He's a librarian at UVic, and he was tasked with conserving the material, and only really via the labels on the discs themselves, the physical labels, did he realize that what they could contain was early computer-generated artwork. And he did a lot of investigative work, and it turned out he was right, and he was able to track down the hardware and emulate the software that he needed to understand these files. And his story is really interesting, and I hope that you have a chance to hear it at some point, or this is the most I could find that's been written about it, but John has been presenting at a couple of conferences about it. So if you ever have the opportunity to hear him talk about it, it's a really fascinating story. So having said all this, my point of telling a little bit of John's story is that if he had been able to have, say, a PRONOM ID for these computer-generated artwork files, which I doubt he would have been able to, because I don't think a PRONOM ID for these really obscure early artwork files exists. I searched this morning actually, and I couldn't find one, but I could be mistaken. But having that file identification in and of itself would not have been nearly enough for him to be able to fully understand these objects and to conserve them and provide access to them in the future. So while it would have been helpful perhaps to record in the technical metadata, especially as the collection grows, and perhaps to be able to compare these files to other files that have come in via other collections, but clearly that information alone is not enough. So I'm going to move on to talk about format identification tools, and this, of course, is a screenshot from the Copter wiki, and we can see, of course, that there are a large number of tools that are kind of classified under format identification. As mentioned already, some of these have overlapping functionality with other digital preservation actions. But before we dive into any specific tools, including Fido, just having a general sense of how these tools work is helpful when navigating the array of the tools available. How does format identification work? So this is a really basic fact, and I'm sure all of you listening are probably aware of it, but generally, extensions are not really considered a reliable method of identification. If you go to your desktop and right-click and change a file extension, then voila, you have demonstrated the problem. It's much more precise, of course, to analyze the actual bits in the file and looking for what's referred to as characteristic codes or file format magic. And these specific patterns of bits within files are what become a signature in a format registry like PRONOM. And I'm going to talk about format registries a bit more in a few slides, but it's worth mentioning that, of course, it's also possible for tools to have their own signatures to check against rather than consulting PRONOM or another registry. One of the benefits of using signatures for format identification is that you can get really specific identification details, such as a particular version of whatever object it is that you're looking at. So maybe you are identifying a JPEG, but it might be important for the preservation of that JPEG to know exactly which version of JPEG, because the file specification may have changed over time. So this is a real-life example of some suspicious file extensions. And these sample files were provided to us for testing by the University of Saskatchewan, who are Archivematica users who we work with at Artefactual. So you can see even just in the file browser that there's something really funky happening with these extensions. They have kind of two, or some of the files in this anyway, have two extensions rather than one. And because it's ending in .doc, the file browser is interpreting this file to be a Word document, but it certainly can't be opened by Word. I don't know, we don't know how this happened exactly, if somebody changed the extension manually for some reason, or if it happened in some other way. This is a collection of things that came from a donor, so I don't think the archivists at University of Saskatchewan know either. So we're going to revisit these files later in the webinar, because in addition to their funky extensions, they also proved a challenge for Fido to identify properly until we've added some new functionality unrelated to the extension problem, but more related to their actual true format. So we'll talk about that a little bit later. So I've mentioned PRONOM and PRONOM IDs, but it's worth mentioning MIME type as well. And I think when a lot of us think about MIME types, we tend to think about the top-level MIME type names like application, audio, image, etc. And sometimes we also think of MIME type as not being much more useful than identifying by extension, because the MIME type can be set manually without matching the actual content in some cases. But the Apache Tika project and the free desktop project have developed signature-based identification for MIME types, and they're particularly good at identifying text-based formats such as XML or code, which PRONOM and therefore tools that interpret PRONOM, like Fido, kind of fall down on. Siegfried being another format identification tool, if you're not familiar with it, and Siegfried has been primarily in interpretation of PRONOM as well, just like Fido is. But Siegfried recently introduced MIME type identification, which its developer, Richard Lehane, he wrote a blog post which is linked on the slide here, on the OPF blog. And by using MIME types and PUID or PRONOM identifiers, you're really getting double the magic, because you get little impact on performance, but you can identify using both. So if there's a format that is something more like a text-based format like XML or code, possibly the PRONOM ID may not be a useful method of identifying it, because it may just come up as sort of a generic text, whereas the MIME type can interpret it to be something much more specific. So that's just something that's worthy of consideration, I think. So now I'm going to talk about format registries a little bit. Definitely like the registry that we certainly spend the most time thinking about and contributing to, and certainly the one that Fido uses is PRONOM. But there's definitely value in considering registries aside from PRONOM when you're talking about format identification. And this diagram, I believe it was created by Andy Jackson, but somebody can tell me if I'm mistaken about that. But you'll find it on the DigiPres Commons format site. And it might be a little bit difficult to see through this screenshot and through screen sharing on your screen now. It's worth going and taking a look and exploring through and clicking through to see the ways that this data is laid out. But what it shows is that there's definitely some overlap between different registries of formats, but not total overlap. And this isn't to imply that we shouldn't continue to grow any one registry, such as PRONOM, and to try to keep it strong, but more to highlight that there are indeed different registries, and they have different approaches and unique focuses. One advantage of PRONOM is its machine readability. It can export in XML, which makes it very useful for a tool like Fido or a tool like Siegfried or Droid as well. And another advantage to PRONOM, of course, is its breadth. Anyone who's used PRONOM knows that it's extremely extensive, despite not having an entry, as far as I can tell, for those obscure artwork files I mentioned earlier. Just about, you can find an awful lot of formats through PRONOM. A disadvantage to PRONOM, though, is that while it's wide, it's sometimes quite shallow. So sometimes you'll find a much deeper dive into some formats on, for example, the Library of Congress format description site, where they've put a lot of effort into analyzing a smaller subset of formats that are of high importance to the Library of Congress. So that's why they've put considerable effort into understanding those formats. However, in terms of that Library of Congress data site, there's currently not any tools that can read the data, but one of my colleagues here at Artefactual has actually had a preliminary conversation with people at Library of Congress to discuss what it would take to add support for identification tool usability. And basically it would come down to some changes in the way that they output XML. So we're hopeful that that might be a possibility in the future. So a useful way of understanding and comparing and contrasting these format registries is to look at the same an entry for the same format in each one. So I thought that we might take a look at the entries for shapefiles in PRONOM and in Library of Congress, FDD, and also the archive team format wiki. Shapefiles are a format primarily used in GIS, and it's not a format that I have really any authority whatsoever to speak about, but they have an interesting characteristic, which I'll get to in just a moment. So this is the PRONOM entry for the ESRI shapefile, and it includes the signature, which of course is on a different tab. I can't screenshot the whole thing at once. And also a brief description of the format and a link to the format's documentation. And the description does mention, and this is the kind of interesting characteristic of what we tend to refer to as a shapefile, is that the shapefile exists within a cluster, and that in addition to this format that it's describing here, and which is identified by the signature, there are two other mandatory files that have to exist alongside that file. So this is the same format, the ESRI shapefile, in the Library of Congress site. We get considerably more detail, which you can't really see in my screenshot, but if you go and visit and take a look and scroll down, you'll see that they've really gone into a lot of detail about the shapefile in this entry, which is really nice. It's a little bit more explicit about these mandatory files in the cluster, and it also provides an extensive list of the possible files that could be in the cluster but are not mandatory. So this is the archive team wiki, which is a great resource for understanding formats as well. We get kind of a similar description as you found on PRONOM. But it does describe, again, the clustered nature of this format. It does use this one entry to describe all three extensions of the mandatory files that you'd find in a shapefile cluster. So you'll see that along the in the file format area on the right-hand side there in the little purple box. So of these three format registries that we just talked about, currently PRONOM is the only, that I'm aware of, the only truly machine-readable one, and therefore usable for format identification in our context for a tool like Fido. But the usefulness of a format registry goes beyond its ability to identify files with code, particularly in this context with what we call a shapefile, which is actually, as I mentioned, like a packaged cluster of files. So having all that contextual information about what you need to find in a shapefile and what you could find in a shapefile is important and not something that can really be expressed in a signature. So on the screenshot here, this is what a shapefile can quote-unquote look like. And this is an example that I found in the Harvard Dataverse database. So we can see that if you take a look at the file extensions, you'll see that the shapefile itself has the .shp extension, and there's also the mandatory other two files in there, which is an index file, which is .shx, and dbase table file, which is .dbf. But as we see in this example, it's also possible to have significant amount of other type of documentation within the package as well. So there's currently, not that I'm aware of anyway, any way for a registry to deliver up some kind of machine-readable way that a signature could describe the requirements of a zipped package so that an identification tool could identify not just the contents within the package, but also identify that the package itself is significant, which obviously could have implications for future preservation initiatives. If you didn't really know what you were looking at and someone deposited to you this this zipped package of all of these things, you may not realize the importance of their interrelatedness. But there's not really any way for us to identify that other than curatorial knowledge, I guess. And just if you're interested, I did run this particular package through Archivematica and identified it with Fido, and all of the contents were correctly identified. The shapefile was identified as a shapefile, and the DBF file was identified as a D-based table file, and so on. But obviously, like I say, there's no way for the package itself to have any meaningful identification other than to say it's a zipped package. Why are there different methods and tools for format identification? So as we've already discussed, in addition to different registries of file formats, there's a lot of different tools that you could choose from to do format identification. And I think really just the reason that different tools exist in many cases is because different developers had just different ideas of how to interpret a registry, or had new functionality or output that they felt was needed for some use case, either just generally or at their own institution. And if you go back to Richard Lehane's first post on the OPF blog, not his first post rather, but the first post that he wrote about Siegfried, is that he really developed Siegfried because he felt he had just an itch to scratch to see what interpreting PRONOM would be like using a different search algorithm. So that scratching of an itch has resulted in a really powerful and interesting tool. And I think Richard pointed out in that post that just the more interpretations of PRONOM that we have, the stronger PRONOM will be. So there's really no harm in having multiple ways of identifying using the PRONOM database. If I were choosing between file identification tools, and sometimes in our Archivematica user community we have people doing exactly this, and I'll talk a little bit about what we include in Archivematica and why in a couple of minutes. So I would just be looking for functionality like the tool output format, issues around performance, that can be a considerable issue depending on the type of files that you're identifying and how quickly you expect things to move. I might consider what type of signature I want to match if it makes more sense in my context to be using PRONOM IDs, or if MIME types, or both, the way that Siegfried can now do, or if there's other kind of special features or flags or parameters that might be handy for my local workflow and my particular needs. So as an illustration of this sort of decision-making process, these are some of the reasons that we've integrated Fido into Archivematica. So for starters, it's run in a way that Archivematica can make use of easily without any forking or special configuration by our developers. It's run via the command line, which is an essential for Archivematica. And it's also written in Python, which makes things a little easier because that's what Archivematica is written in as well. It's pretty fast, although we could probably do some up-to-date benchmarking against other tools just to give us some better data on that front. And it's based on PRONOM, which we understand to be important to at least some members of our user community. They seem to feel that that is of value as well. But it also gives us the opportunity to interact with PRONOM by submitting test files and encouraging our user community to do the same. We really admire PRONOM not just for its technical aspect, but also because it's an initiative that we agree with on a philosophical level. It's something that we can all contribute to and make stronger together, and that really works well with the open source philosophy that we take to all of our work that we do at Artefactual. And finally, of course, Fido is open source, and Archivematica is an open source platform that bundles together many other tools. So just on a practical level, if not a philosophical one, if we want to package and release something as an Archivematica dependency, it needs to be open source just for licensing purposes, if for no other reason. So we're of course happy to encourage Fido use in Archivematica, but we also feel it's important to have choices. So we were pretty excited to add Siegfried version 1.0 in the 1.4 release of Archivematica, which was last year. And in the upcoming 1.5 release of Archivematica, which is due out just about any week now, we'll release with the recent Siegfried 1.5 release. So up-to-date Archivematica and up-to-date Fido and up-to-date Siegfried. So that'll be really good. Our user community has definitely been thankful for the choice, and there's a couple of things that we've noticed sort of off the bat from our own testing and from feedback from the user community. Siegfried was able to properly identify some container files, which Fido previously missed. We've since fixed this in Fido, and there'll be more on that at the end of this presentation when I in Fido. They've also been really pleased with Siegfried's speed and comprehensiveness, how far it will read into a file and how accurately it identifies. If a user is using Siegfried via the command line rather than just interacting with it through the Archivematica installation, they can also take advantage of some useful output information such as warnings for extension mismatches and other possible problems. So we tend to encourage Archivematica users to think of Fido and Siegfried as their first choices, but we also have as sort of this fallback method format just by file extension. And this can be useful in some cases when you have kind of an unusual file that's not in PRONOM, and you need to identify it in some manner or other. Although we would always encourage our user community, if they found something that cannot be identified by any interpretation of PRONOM, then to submit it to PRONOM so that it can be included in a future signature release. And we ship Archivematica with these defaults, but file identification is one of several preservation actions in Archivematica that can be configured using what we call the Format Policy Registry, or FPR. And through the FPR, you can add new rules and commands in addition to the Archivematica defaults. So if a user has the technical know-how to install a new tool and write their own commands and rules for identification, they could do that as well. How do you choose between the tools? And we do sometimes have our Archivematica community members asking us, how do I choose between Fido and Siegfried? So my recommendation is always giving the documentation or the man page or the help page a really good read and experiment with different flags or parameters. If it's relevant, you could also consider the type of material you work with generally if you do have a general use case. So for example, Media Info is a particularly good tool for audiovisual materials and has a lot of users in the audiovisual preservation community, so that might be something to consider. Running experiments by identifying the same file with different tools and comparing their output and deciding which of those is most useful to you seems like an approach to take. And I think it's important to keep in mind that you're certainly not the first person to try to crack this nut. It's worth engaging with your professional community on listservs or blogs and ask for opinions. And if you search, for example, for identification on the OPF blogs, you'll find many great posts on this topic, and that would give you a huge head start in your thinking about how you're going to go about this. So now I'm going to go through a couple of sample workflows, and as I mentioned, these are both drawn from the Archivematica community, but I'll try to describe them in such a way that they're generic enough that you could think about them outside of the Archivematica tool. So this workflow to deal with failed identification was first described as part of a JISC-funded project led by University of Hull and University of York, and they're currently in their phase 3 of that project now. They've been really, excuse me, they've been really proactive about disseminating their work on this project, so it's pretty easy to find, but if you are interested in learning more about it and are having trouble finding their reports and so on, then feel free to get in touch with me, and I can send you some links and so on. So file format identification was of particular interest to this project, or continues to be of particular interest to the project, because of the realm of research data management. And where in research data management, there are just a great deal of formats being created by researchers in many different fields. So if you're responsible for data management at your institution, you're almost certain to come across some kind of format that PRONOM has no entry for. So at its most basic, the team wanted to ensure that the files that could not be identified by the primary identification tool, whatever you've chosen that to be, could be then rerun through to identify files that failed with a secondary tool, or alternatively, to submit the failed files to PRONOM so that they could be included in a future signature release if they don't seem to be identifiable by anything. So this may seem like a fairly basic premise, but we did encounter some interesting design implications in terms of implementing it in Archivematica. So this was the basic design describing the workflow. To understand it, you may need to understand that Archivematica's design is one of microservice-based chain links. So the digital objects move through an Archivematica pipeline, going from task to task and gathering technical metadata along the way. So file format identification is one of the earlier microservices that Archivematica performs in its process, and then it moves on to things like characterization and validation and so on. So in this scenario, we proposed an additional link in this microservice chain link to deal with files that were not identified by the first identification command that we ran. So this raised a lot of questions, though. So currently, as I mentioned, by default, Archivematica uses format identification tools that are based on PRONOM, with the exception of by extension. So if Fido couldn't identify the file, is there much benefit in then running Siegfried or vice versa? And this was debated a bit amongst the people involved in the project, and I think we kind of concluded that in some more rare cases, you might get a positive ID out of Siegfried or Fido when you didn't with the other, but in general, because they both use the PRONOM registry, it seems a little bit less useful. Having said that, now with an updated version of Siegfried, you could also identify with MIME type, so that might be a useful thing to think about in this workflow as well. An interim measure with these currently available tools, and what we thought would be a possible scenario for unidentified files, would be to pause before re-identifying, add the formats manually to Archivematica's format policy registry, and that way they could at least be identified by extension. So if you're able to use the file format extension to get any kind of information about the file format, like at least its name, I suppose, and its extension, then you could add it manually to the Archivematica format policy registry and have it identified by extension. It's going to mean that the tool output for further microservices like validation and characterization may not be as rich, but at least you've gotten a start, and you could maybe store the files away until such a time that they've been added to a PRONOM signature release and run the files again. So as part of this work, we consulted with some Archivematica users, or rather, the archivist from Holland York did. Jen Mitchum particularly led this initiative to engage with other Archivematica users and ask, what do you think is the most important thing for Archivematica to do when it encounters unidentified files? And most of the users that we consulted seemed to agree that better reporting for showing which files had failed identification was an important thing to have. So this is an early prototype. And what it shows is a report that has the files that couldn't be identified in sort of a report-based format. And then it's not shown in this particular screenshot, unfortunately, but we later then organized these by extension, because we figured if you're dealing with a transfer that has hundreds of files, you kind of want to organize them in some manner to be able to parse through them. So we also planned to implement the ability to select files or select all of the files by extension and then re-identify them with a chosen tool. So the defaults, as I mentioned, right now are Fido, Siegfried, and by extension. But the nature of that format policy registry would also allow individual institutions to install and create commands for further tools if they so desired. So this is another example of a workflow that I'll describe in the way that Archivematica is going to employ it, but you could certainly think about the way that it would be implemented in a different digital preservation system or just by a sort of manual way of managing archival information packages. So suppose in the last scenario, the archivist were unable to definitively identify some of the files, but chose just to create an archival information package and store it for such time that those files could be identified. I would suggest, of course, as I've mentioned, that one of the best ways to make these files quote-unquote identifiable in the future would be to submit submit samples to PRONOM whenever possible, just so that we can make the database more comprehensive, and then those files would hopefully be identified by Fido or Siegfried or Droid in the future. So once those formats are in a PRONOM release and the tools are updated, the archivist would then be able to pull the AIP out of archival storage with the offending files back into the digital preservation system, in this case Archivematica, and rerun file identification so that they could be accurately identified. That implies also that you could also rerun your other digital preservation tools. So if now you have identification information, it's a good time also to rerun characterization and validation and possibly normalization if that's part of your preservation workflow. So this workflow could also be relevant if the file format that you initially got from file identification was successful but maybe suspicious. So later when I talk about the updates that we've made to Fido, I'm going to talk about container files and how Fido used to identify these container files very generically, but now is able to get more precise identification information. So that'd be another use case where you might want to do this kind of workflow. This is how the workflow plays out in Archivematica by way of the metadata. If you're an Archivematica user and you're listening to this, this particular workflow will be available in Archivematica 1.6. But Archivematica records all of its preservation and technical metadata in a premise and METS XML file, which is stored in the AIP. And this is an example of a METS file for which an AIP has been re-ingested. So the first time that it was processed and placed into storage, file identification was skipped. And when it was re-ingested, Fido was run for format identification. So the bottom circle that you see in the XML there, where it says format name unknown, this is because the format identification was skipped, so Archivematica has no way of recording what file format it may be. And up at the top of the section of this TechMD, or technical metadata, you can see that the status of this particular section of the XML is marked as superseded. And that's because it's the initial, now outdated metadata from the first time that the AIP was processed. So this technical metadata is below that slide we were just looking at. And now we're looking at technical metadata with the status of current because it was produced during APE re-ingest. So now Fido has been run, so we can see that the format has been identified as JPEG 1.01. And if you could see the rest of the metadata for this object which follows below, later you'd also see a format identification event which names Fido as the tool that was run for format identification. So it's time now for an update on Fido. So as I mentioned in my introduction, Artefactual Systems is assisting OPF with the maintenance and release process for Fido as part of our affiliate membership with the OPF. And we've added new features to improve the identification of container formats, and also updated the PRONOM signatures and made some changes to the packaging and code of Fido for this release that's happened just today. So first, a little bit of an explanation of the first type of container that Fido can now identify properly, and these are zip containers. So these are all of those pesky Microsoft-based extensions that have X on the end as examples of zip containers. So things like docx or XLSX. So in previous versions of Fido, when you ran these files, they were all identified as a zip format. And the reason for this is that the compression of the container was preventing that magic byte matching from working. Now it works properly, and as you can see from Fido's output here, so highlighted in yellow in each of the before and after is how Fido had identified the file. So you can see initially it was identified as a zip, and after it was identified as Microsoft Excel for Windows. So a second type of container that Fido can now handle correctly is an OLE container, which stands for Object Linking and Embedding. And these containers allow for linking and embedding of documents inside each other. So that kind of creates a container format. And for our sample file on this fix, we use those samples from the University of Saskatchewan that we were talking about earlier with these funky file extensions. So aside from the extension problem, which a tool like Fido can easily overlook, it turns out that these files were OLE containers. So every time Fido was run on these documents in this sample that was provided to us, they were all identified as just a kind of a generic sounding format, OLE compound document format. Doesn't really tell you exactly what the format was. So now when this particular file is run through Fido, it is identified more precisely as a Quattro Pro spreadsheet. I should mention that of the files, that the 5 sample files that we've tested with so far, 2 of them were still being identified as OLE containers by Fido 1.3.3. And we're not sure yet if this is a problem with these particular files. Maybe there's something weird about them, or perhaps the PRONOM signature for their true formats is either needs some adjustment or doesn't exist. But we plan to investigate this a little further soon. So in the meantime, Fido is being released definitely with improved handling of OLE formats. So if you give this a try and you experience either success or failure, we'd love to hear from you. And if you do have some samples that still can't be identified properly, then maybe we can coordinate our efforts on getting them submitted to PRONOM and figuring out what's going on there. So the PRONOM signature release that came out in January of this year, version 84, is included in this release of Fido. So if you haven't already taken a look at that release and you've been having problems identifying some formats using a tool like Fido or Siegfried, you might go in and take a look and see if your formats are on the list of either new or updated. And a couple of other changes and fixes that we've made. Fido is now has support for Python 3, although it still works with Python 2.7. We've improved the packaging, including adding Fido to the Python package index, or PyPy. So it's now really easy to install Fido. You can just, if you have pip installed on your computer, then or in your environment that you're doing your digital preservation work in, then you can just do pip install OPF Fido, and Bob's your uncle. So we're pretty excited about that. We've also added tests and some minor bug fixes to the code, so things that will make release processes and bug fixing and testing easier to do in the future. So these are just some blue sky Fido ideas, and the first 2 are just completely shamelessly borrowed from Siegfried. So things that we've been talking about a little bit at Artefactual, and that would be happy to talk about more with the user community and to have conversations with the OPF about, is just as examples. Like Siegfried can now do, should Fido also be able to use MIME info signatures? Is that a useful use case, or is it enough that we have one tool that can already do that? We've also thought about giving Fido more ability for signature customization, and this is something that, if you haven't looked into it already, you can do with a sort of side application to Siegfried, appropriately called Roy. So we're curious to know if there's use cases for something similar for Fido. You can add some flags and parameters to your Fido running. So when you run Fido, you can say identify using this subset of signatures, or don't include this subset of signatures. But having something that you can kind of author more customization seems like it might be a useful thing. This is real blue sky, and I don't know what the technical possibilities are, but we've tossed around the idea in the office that, could a format tool someday correctly identify a package format like those shape files, something that is a zip container but has an internal structure of some kind that has certain requirements, and could that be identified using a tool like Fido or Siegfried? I think it depends more on the signature availability. So the question might be more: is it possible to write a signature for that kind of clustered format? And we'd love to hear your ideas. So if you would like to get in touch with us, my contact information is on the next slide, or you can get in touch with the OPF, or you can reach us on, you could file an issue on GitHub, for example. So hopefully there's a way that you could get in touch with us that you're comfortable with, and we'd love to hear what your thoughts are for the future of Fido. So before we get to questions, I just want to do a quick thank you. Thank you, of course, to the OPF for having us today. And I kept referring to we and us as I talked about Fido development, but I'm not a developer. I'm just the person who gets to talk to the community about it. So I really want to just recognize the development team at Artefactual, who have been working on this most recent release of Fido. And that's Holly Becker, Misty DeMeo, who no longer works for our company, I'm sorry to say, but she put an awful lot of effort into those container fixes before she finished her work with Artefactual, Jesus Garcia Crespo, and Justin Simpson. And my contact information is there. I'd be thrilled to hear from you. And if you don't know it already, there's Fido on GitHub if you'd like to take a look at the code or file an issue or something like that.
Sarah, thank you very much for your presentation. I really enjoyed it and found it really interesting, and thank you everyone else for attending. As I said, I'll try and gather the slides, recordings, links and other bits and pieces all together, and you've got Sarah's contact details on there should you think of any new questions afterwards.
Thank you very much, Becky.
Right, thanks very much everyone, and bye.
Bye.